Hello there. In this video, we will be talking about the 3 most popular UML diagrams used by a business analyst. We will go over ER diagram, activity diagram and use case diagram with examples. Let's begin with ER diagram. Hello there. Are you wondering how online websites and mobile apps store, retrieve and show different data types and the volume of data? This is because of the creation of database, which is an organized collection of information where data is stored, managed, updated and retrieved. Databases have many elements and understanding how they interact with each other is complex. This is where ER diagrams are used. By the end of this video, you will be able to know what an ER diagram is and why it is important in businesses and in software development. Components of ER diagram will also be discussed with an example case study. Without further ado, let's get started. Tina is a system analyst and IT BA. She is working on a mobile application for online food delivery for the client Vegan Gardens. As a part of the design phase of the project, she is asked to create an ER diagram so that the developers and database administrators can understand the data requirements and create the required tables. Let's see how Tina creates it step by step in the upcoming slides. Stay tuned. Before we dive to create an ER diagram for our case study, let us spend a couple of minutes to understand what an ER diagram is and why it is needed. ER diagram stands for Entity Relationship Diagram. It is also known as ERD. It is a visual representation of how tables, also known as entities in a system, are related to each other. One advantage of using ER diagrams is that it makes it easier for business folks to understand the data because it is presented in a graphical manner. In business analysis, ERD is a vital part of designing software systems. ERDs are mainly used by analysts in designing database, especially when handling complex data. Another advantage is that it helps in communicating the landscape of business to different teams, which helps them understand the overall structure of the business. This organized information is useful for business management and formulation of strategies. Now, let's proceed to the components of the ER diagram. It has 3 key components. The first component is entity. Entity can be a person, place, event or an object that is relevant to a given system. One entity represents one table. It is indicated by a rectangular box in the ER diagram. The second component is attribute. An attribute is a property, trait or characteristic of an entity. Attributes are listed within the entity. Under the attributes are the keys which uniquely identifies the record of the entity. It includes primary key and a foreign key. Primary key is a value which uniquely identifies every row in a table, while foreign key is a value that matches a primary key inherited from some other table. Lastly, the third component is the relationship. Relationship describes how entities are linked to each other. In ER diagrams, relationships are represented by cardinality, which defines the possible number of occurrences in one entity which is associated with the number of occurrences in another. Now that we know the components, let's go back to our case study to further understand how these components are used in ERDs. First, Tina must define the first component, which is the list of entities. She has grouped the data into 4 entities. Each table is equivalent to one entity in a database. As mentioned earlier, the entities are represented by a rectangular shape with details of the data at the header. The entities she included are entity number 1, customer information to store the customer details. Entity 2, food catalog, which will store the list of food items available for home delivery. Entity number 3, order details, which will store the details of the order. And entity number 4, the delivery details, which will store the details of the home delivery. Now that Tina already created the entities, the second step is to fill the attributes list for each entity. For the first entity, Tina lists the information related to the customer, that is their name, address, phone number, etc., and a uniquely generated customer ID is tagged as the primary key for the table. As stated earlier, primary key is a unique value for each row and this will be used to identify the customer. For the second entity, list of food items available for home delivery, she includes a unique ID, that is food ID, its description and an image for the same. The primary key is the food ID for this table. The third entity is the order details. It stores the order ID and the order item number. If there are multiple items ordered, this will be an incremental number. Combination of both order ID and order item number form the primary key for this table. Then it has the customer ID of the customer who has ordered, food item details, quantity ordered, amount, and lastly a delivery tracking number for tracking the delivery of this order. In this table, you can also see 3 foreign keys which provide linkage to other tables. Customer ID is a link to customer information table, food ID is a link to food catalog table, and delivery tracking number is a link to delivery details table. Lastly, delivery details table which contains the information related to delivery like who is doing delivery, delivery time and the status which would be updated once delivery is completed. Now we have defined the attributes, let's move on to the last component. Component number 3, relationships. What is shown in this slide is the relationship between the entities defined by Tina earlier. We know from our previous slide that the order detail entity has relationship with all the 3 entities. Now Tina has to document the type of relationship between each of them, which is component number 3. I will only touch upon 2 types of relationship which is most commonly used in the ER diagrams. Relationship type number 1, one-to-many. Let us look at the relationship between customer and order details. One customer can have many orders. Hence, the relationship is denoted by one-to-many symbol as shown in the diagram. Similarly, relationship between order details and food catalog is also one-to-many. That is, one order can consist of many food items. Now let's look at the second relationship type number 2, one-to-one. Between order details and delivery details, there can be a single delivery for a single order. That is, the delivery person would deliver the whole order and the relationship between these 2 entities is one-to-one only. This means that one order can have only one delivery tracking number. It is denoted by one-to-one symbol as shown in the ER diagram. Through the relationship of the entities presented, we can now visualize how these entities relate to each other. Now you can see how the ER diagram can visually show the DBA or developers how the data has to be stored and the relationships between each other. Finally, to summarize, ER diagram is composed of 3 components: entity, attribute and relationship arranged in a graphical manner in a diagram to easily understand the data. Now that you know everything about ER diagrams, it is time for you to organize your data and make your own ER diagrams. Remember to enjoy the process too. You can use tools like diagram.io, Lucidchart, Glyphy, MS Visio and so on for drawing the ER diagrams. Let us know your preferred tool in the comment box below. Don't forget to click on like, share and subscribe button if you like this video. See you in the next video. Let's move on to activity diagram.
Hello there. It has been a while, but we are back with a brand new video. Do you have trouble making the development team understand the list of things the system should do and also in what order it has to be done? Then this is the video for you. In this video, we are going to cover the concept of activity diagram, another skill to add to your expanding BA toolkit. Let's get started. As the name suggests, activity diagram is a type of diagram. You may have heard, a picture is worth 1,000 words. Activity diagram is a type of UML diagram and is a visual model showing the sequential flow of activities to achieve an outcome. It is usually used as a graphical representation for a specific use case or a scenario. It can also be a supporting document for a user story if being used in the agile context. As always, let us use a simple case study and draw an activity diagram for that. James is a BA working with a client running a restaurant called the Waken Gardens. The client is looking for a mobile app which will allow their customers to book a table. James is going to draw an activity diagram for listing the activities involved and their sequence for the table booking use case. Let's see how he does that. To simplify, an activity diagram has 6 key components. As mentioned in our case study, James is going to document the activities for table booking and the flow using an activity diagram. We had covered how to draw a use case diagram in one of our earlier videos, and one of the use case was table booking, and this activity diagram is based on it. You can check the use case diagram video using the link in the description box if you want to learn more about the use case diagrams. Okay, coming back to the activity diagram. Let's get started with our first component, swim lanes, which help to separate the activities clearly between the customer and the system, which help to easily visualize what activities will be performed by the customer and what will be the activities done by the system. The next component is the start icon. It is used to indicate the starting point and is usually indicated by a black circle as shown. The third component is the activity box, which indicates the activity. The first activity on the list is the customer clicking the book table button, which will prompt the booking system to display the screen asking the customer to enter the date and number of guests. Then customer enters their preferred date and number of guests. Let's say 10th May for 5 number of guests, and then click on submit. The next activity is that the system would need to check for the table availability for that date for the mentioned number of guests, which brings us to the component number 4, a decision box. If the table is not available, then system should display a message indicating table is not available, which will terminate the activity flow indicated by the next component in our list, number 5. If table is available, then all the available time slots are displayed to the customer for selection, like 12:30, 1:30, 2:30 and so on. Customer clicks on the preferred time slot, then the system needs to book the table on the back end, and once that is done, we have the final component, component number 6, the horizontal bar. We have 2 types. The first one here is called as fork, which indicates splitting of the flow and to showcase the parallel activities like the ones listed below. Sending SMS to the customer's registered mobile number with booking confirmation. Email to the customer's registered email for confirmation, and making the booking activity on the customer's home page in the app so that in case if the customer wants to amend, they can view and amend easily. Once all the 3 activities are completed, then we have another horizontal bar. That is the second type, and this is to indicate the joining back of the flow, and the next activity will only be done if all the 3 parallel activities are completed. Once all the parallel activities are completed, then booking confirmed is displayed to the customer on screen, bringing an end to this use case. We can still have few more activities listed to make this in depth. I restricted to fit on a single page PPT. Hope you find this technique useful and start using it in your next use case or user story where you want to represent the activity flow.
Next, let's look at the use case diagram.
Welcome to the use case diagram tutorial. In this video, you will learn what is a use case diagram and its use. You will also learn the components which make a use case diagram, and we will go over those components one by one. Lastly, we'll build a use case diagram for a case study involving a table booking app. Now let's look at a use case diagram. It looks like what you see on the screen right now. The purpose of a use case diagram is to demonstrate the different ways that a user might interact with the system. It is helpful in documenting the functional requirements and will help the development team to build a solution in line with the business requirements. Does the diagram look complex to you? Let us break it down into components. Number one, represents the users who will be interacting with the system. The actors can be a person, organization, or another system. There are two types of actors, primary and secondary. Primary is an actor who triggers the use case. Secondary is an actor who participates in a reactionary way to complete the goal of a use case. Primary actor is indicated on the left side and secondary actor is indicated on the right side of the use case diagram. Component number two, system. System is a solution which you are developing. It can be a website, application, or a software component. It is represented by a rectangle with the name of the solution at the top. Number three, use case. It is depicted by an oval-shaped icon and describes what the system does. A use case has a unique name. The name describes the action taken by the actor. They are represented within the rectangle, the system that is, and forms the scope of the solution being developed. Number four, associations. These represent the relationship between the actors and the use cases. They are represented by a straight line as shown in the presentation. There's another set of relationship, that is a relationship between the use cases. They are indicated by a dotted line with the words include and extend written on them. Include use case in simple words is a use case which is always invoked by the base use case. It is separated out so that this use case can be used by others as well. For example, a shared functionality required by several use cases can be an include use case. Now let's go look at extend use case. It represents an alternate flow, and this is triggered only under certain conditions. Now let's look at the use case diagram again and let's identify the four components which we just discussed. First off, actors, primary on the left and secondary on the right, indicated by number one. Secondly, the system, which is represented by the big rectangle in the middle, represented by the number two. Thirdly, the oval-shaped icons, use cases, and lastly, number four, the association, the relationship between the actors and the use cases. Hope the use case diagram looks simple for you. Next off, let's build a use case diagram for a case study. James is a BA working with a client running a restaurant called Vegan Gardens. He's looking for a mobile app which will allow their customers to book a table. James is going to document the user interactions through a use case diagram for submission to development team. The restaurant owner are requested for the following features. The customer should be able to register, then they should be able to log in and book a table, and also he would like this app to check the availability before confirming the table to the customer and also display an error message if the table is unavailable. Now let's start off and build a use case diagram for this. First off, we start off with a big rectangle in the middle to indicate the solution, and let's name it table booking app because that's what this app does. Then secondly, we start off with the actor. The main focus in the solution is the customer who will be using this app to book tables. Hence, he is a primary actor indicated on the left side. Then we start off with the third component, the oval-shaped icons, namely the use cases. So the features of which were requested would be different use case. So let's start off with the first feature, which is the registered. Second one is a login. Third one is a book table. So these are the three basic features which the client has requested. And now let's link them to the actor with an association by a straight line. So this indicates that the customer is interacting with the solution to do these particular features. Now, once the customer has booked the table, the restaurant needs to be notified and the table needs to be blocked. This is represented by the restaurant as a secondary actor and adding an association, which is a straight line between the restaurant and the booker table use case. Now let's look at some additional features which the client has requested. So before confirming the table reservation, the app needs to check for a table availability using the restaurant system. Since this use case would be invoked every time when you book a table, so this relationship is a include relationships as indicated by a dotted line and the words include written on it. Also, if it's an include relationship, there is an arrow which was pointing towards the derived use case, which in this case is check availability. Let's say if the tables are not available for a particular day and time which the customer has selected, then an error message needs to be displayed. Since this use case is triggered only in a condition when the table is not available, this is indicated by an exclude relationship with the dotted lines and the word exclude written on it. And the exclude relationship is usually represented with an arrow facing the base use case, which is book a table. So with this diagram, the development team would be able to visualize the different features and the interactions, and they will be able to develop the app according to the requirements.